Video presented to you by Unique to Billions e-learning. Please subscribe it and press the bell icon. Dual nature of radiation and matter. Traditionally, particles and waves are treated as separate components. We have already studied wave nature of light in cases like diffraction, interference, polarization, etc. But there are some phenomena which are not able to explain with the help of wave nature of light. It requires to consider radiation as a stream of particles. So, radiation have dual nature, that is both particle as well as wave nature. In the same way, matter, for example electrons, which are particles with charge and mass, also shows wave nature. In this chapter, we are going to study about this dual nature of radiation and matter. In this video, we cover electron emission, work function, and three different ways of electron emission. There are free electrons on the surface of a metal. These electrons are held inside the metal surface by the attractive forces of the ions. If the electron got enough energy to overcome this attractive pull, it can come out of the metal. This minimum energy required by an electron to escape from the metal surface is called the work function of the metal. What is work function of a metal? It is the minimum energy required by an electron to escape from the metal surface. Work function is generally represented as phi and it is measured in electron volt. This unit of energy is commonly used in atomic and nuclear physics. The work function depends on the properties of the metal and the nature of its surface. Here we got one more term, electron volt. So we need to define the term electron volt before going further. Electron volt is a unit of energy commonly used in atomic and nuclear physics. 1 electron volt is defined as the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. We know if a charge Q is taken through a potential difference of Vb minus Va, the electric potential energy is increased by Q into Vb minus Va. Here, charge of electron E is equal to 1.602 into 10 raised to minus 19 coulomb, and potential difference is 1 volt. Therefore, 1 electron volt in terms of joule is equal to 1.602 into 10 raised to minus 19 into 1 joule. That is equal to 1.602 into 10 raised to minus 19 joule. Now we are going to study types of electron emission based on the ways by which required energy can be supplied to free electron. So there are three main ways by which required energy can be supplied to free electrons so that it can escape from metal surface. They are thermionic emission, field emission, and photoelectric emission. 1. Thermionic emission. When a metal is heated to a high temperature, that means thermal energy is given. Then electrons get thermal energy and are able to escape from the metal surface. This phenomenon is called thermionic emission. Depends upon the way the electrons are emitted, the electrons are having specific names. In this case, the electrons that are coming out through thermionic emission are called thermions. Now, second type is field emission. In field emission, electrons are pulled out of the metal by applying a very strong electric field. That is of the order of 10 raised to 8 volt per meter. This type of electron emission are called field emission. The electrons emitted in this method are called field electrons. Now we are going to see the third type. It is photoelectric emission. Photo means light. We know light have energy. So in this case, energy is given in the form of light. So in photoelectric emission, electrons are emitted from the metal surface by illuminating it with light of suitable frequency. These photo or light generated electrons are called photoelectrons. We will study more about photoelectric effect in other sections. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.